We're still working on the same standard, solving linear equations. All right, the kind of equations that we're working on right now are infinitely many, no solution, and one solution. It is determining how many solutions that you have in an equation. All right, if you notice this one, if I solve it and I subtract 2x from this side and move it to this side, I end up with 0x plus 3. 0x is 0. That means that the variable just went away and disappeared. Now, I end up with 3 equals 7. Is that a true statement? No, it is not. It is never true. Therefore, that has no solution. If I end up with a dumb answer or a stupid answer, 3 doesn't equal 7. If I end up with that, that is no solution. All right, here we have to distribute first. We end up with 3x plus 12 equals 3x plus 11. Move the 3x over. Again, we end up with another scenario where we have 0x and the variable disappears. Does 12 equal 11? No, it does not. Therefore, this is no solution. Once again, to move the 2x to the left, this becomes 0x. Now I have 3 equals 3. Is that a true statement? Yes, it is. It is always true. So if I end up with a true statement, my answer is infinitely many. This one is infinitely many. Now, let's take this one and let's do it. This is negative 2x minus 6 equals negative 2x minus 6. Infinitely many. You can sometimes recognize that right here because this is the same thing on this side as it is on this side. And I went on down here and solved it on out. Pull the negative 2x to the left by adding. That ends up with 0. And negative 6 equals negative 6 is a true statement. Therefore, it is infinitely many. Now, if we're asked to create an equation and we want to create one that has one solution, notice creating an equation using any number we want as long as we don't have the same amount of variables on both sides. Look, I've got 2x, I've got 4x. As long as these numbers are different, I will have one solution. It's when they are the same. If you go back and you look, these are the same. These are the same. 2x, 2x. 3x, 3x. They're the same. So when my variable is the same, I'm either going to get infinitely many or no solution. So as long as my variable is the same, it doesn't matter. Now, or is not the same, I will have one solution. Now, I can also create one that had the same number on each side, like this, but different variables. That's still going to give me one solution. It doesn't matter whether the number is the same or not. It matters whether the variable is the same or not. So if the variable is not the same, I'm going to have one solution. Be very, very careful. This is a common mistake. If you see 2x plus 32 equals negative 2x plus 32, that is not going to be infinitely many or no solution. Be very, very careful. 2x and negative 2x are not the same. Creating a no solution scenario. If my variable, if I have the same amount of variable, meaning the same coefficient in front of the variables, but I have different amounts with the numbers, my numbers are different, then that's the scenario that ends up with no solution. You see I have 5x, I have 5x. That ends up with no solution. The original equation's right here, but you need to look at the amount of variable that you have. If your variable is the same and your number is different, no solution. If I'm creating a problem that has infinitely many solutions, my variable will be the same and my number will be the same. When that happens, that's infinitely many. So in this particular incident, I add like terms, I have the same amount of variable and the same amount of number. When I move this over, the variable becomes 0. I end up with 5 equals 5, which is a true statement. Again, here's another pitfall you might run into. I have the same amount of variable, but my numbers are not the same. Be very careful, just because you see 2 5s or 2 2s or whatever it is, make sure they have the exact same sign as well. These do not. That would be no solution. That would not be infinitely many. So this particular incident has no solution. So be very, very careful. You might want to take your problem on out and just make sure. Take it out a little further than you think and make sure. Thank you.